Okay, so the next thing that we are going to start is carbonyl carbons, right? Carbonyl carbons. Next thing is what? Carbonyl carbons. Now you need to understand this. This is the new chapter which is known as carbonyl carbons, and how many carbonyl carbons we have, or how many carbonyl carbon homologous series we have. A carbonyl carbon is a such compound, or a carbonyl carbon chain is such chain in which we have carbon and oxygen double bond. Only this, not attached OH over here as well, right? Only carbonyl C double bond O. C double bond O को carbonyl group कहते हैं, ठीक है ना? इसके साथ अगर OH अटैच हो जाएगा या सिर्फ O अटैच हो जाएगा तो वो कार्बोक्साइल ग्रुप कहलाएगा, ठीक है ना? तो राइट नाउ कार्बोनाइल कौन सा है हमारे पास? या तो इसके साथ सिंगल H अटैच हो जाए, दिस इज ये हो सकता है, या H ना अटैच हो, दोनों तरफ कार्बन चेन अटैच हो जाए, तो ये कार्बोनाइल हो सकता है, ठीक है ना? एंड दिस इज व्हाट? एल्डिहाइड, एंड दिस इज व्हाट? कीटोन वी हैव इन आवर सिलेबस, राइट? और जो बाकी आपने पढ़े हैं दैट इज लाइक दिस, आपके पास कार्बोनाइल कार्बन तो होता है बट उसके साथ O और H अटैच हो जाता है, तो फिर ये कार्बोनाइल नहीं रहता, इट इज this is carboxyl. This is carboxyl functional group, right? So you can say that this is carboxyl carbon. इसके साथ C double bond O लगा हुआ है और फिर OH भी लगा हुआ है, ठीक है? This is carboxyl carbon, right? और जिस homologous series में carboxyl carbon होता है, या तो वो carboxylic acid हो सकता है या वो ester हो सकता है. It will be like this, कि C double bond O और दूसरी कार्बन की चेन लगी हो. So this is carboxylic acid, right? And this is ester. So we have 4 different functional groups, or we have 4 different homologous series. These are, right? And these 2 are carbonyl, aldehyde and ketone, and these 2 are carboxylic acid and esters, right? We already did carboxylic acid and ester. Now we are moving towards carbonyl carbons, or carbonyl functional groups, or carbonyl chains, right? So you need to understand this, that you just give me a minute, right? Let's start again. हम पढ़ रहे हैं क्या बच्चों? हम पढ़ रहे हैं कार्बोनाइल कार्बन्स वाले, हम पढ़ रहे हैं फंक्शनल ग्रुप्स, राइट? और ये हमारे पास सिर्फ 2 हैं, एक एल्डिहाइड है और एक कीटोन है, राइट? सो फर्स्ट वी आर गोइंग टू स्टार्ट विद एल्डिहाइड्स, राइट? फर्स्ट ऑफ ऑल यू नीड टू अंडरस्टैंड कि ये एल्डिहाइड कौन सा फंक्शनल ग्रुप है बच्चों? इट इज कार्बोनाइल कार्बन के साथ H डायरेक्टली अटैच है, ठीक है ना? और यहाँ कार्बन की कोई भी चेन हो सकती है, बट यू नीड टू अंडरस्टैंड दिस. आपको देखकर पहले तो पहचान में आना चाहिए यार ये फंक्शनल ग्रुप एल्डिहाइड है. जब तक आपको ये पहचान नहीं होगी ना, तो कोई फायदा नहीं है आपको इसके रिएक्शंस पढ़ने का, इसकी प्रिपरेशन पढ़ने का, और इसकी जो है केमिकल प्रॉपर्टीज वगैरह पढ़ने का कोई फायदा नहीं है. तो पहले आप इसको पहचानेंगे ये एल्डिहाइड, देन बाकी आप सारे काम कर सकते हैं, राइट? तो फॉर एग्जांपल सबसे पहले अगर मैं आपको बताऊं कि हाउ कैन वी नेम दैम, सो फॉर एग्जांपल इफ यू हैव दिस स्ट्रक्चर, so how can we name this structure? This is actually, we have 2 carbons, right? And this is aldehyde, right? So we know that 2 carbons means eth, and right now we are talking about aldehyde. So in the aldehyde we can use the suffix which is anal, right? So the name of this is ethanol, right? And you can even write the condensed formula of this like CH3CHO, right? So you need to remember this is ethanol, right? And for example, if you have CH3 CH2 CHO, so this is what? Propanol, right? This is what? Propanol, right? And same, for example, if you have 4 carbons, right? And on the after the 4th carbon we have 5th carbon on which we have functional group, right? And over here, for example, I am writing a branch. This is like one of the structure we have of aldehyde group, right? So what should be the name of this? Remember, from where you are going to start the numbering, from where you are going to start the numbering of methyl or 4-methyl, right? So you need to keep remember, bacho, the aldehyde functional group is always at the end, right? It cannot be substituted in the center somewhere, so it is always at the end. So we need to start numbering from where the functional group is there, right? So it is 1, 2, 3, and 4 carbon, right? So you can write down the name of this is 4-methyl fourth carbon पे आपके पास methyl है, right? And we have 1, 2, 3, 4, 5 carbons in the main chain. So you can say that it's 4-methyl pentanol, right? Is that right, बच्चों?
Yes, sir.
And then, for example, if you have ketones, so ketones are always in the center, right? Because on the both sides we have carbon chains. So ketone can be in the center, right? So for example, if you are talking about ketones, so it is C double bond O, and on both sides we have carbon chains. So in this way, you can write the number at which carbon the ketone functional group is present. So for example, if you have 1, 2, 3, 4, 5 carbons, and on the second carbon we have C double bond O, and this is H, 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 and H. So this is actually 5 carbons. So you can write it is 5 carbon, pent, right? And it is pentane, right? And you need to keep remember, K, whenever you have ketone, you need to write anon, right? So it is pentanol. It is pentanol. And you can see this, that the functional group of ketone is on the second carbon. So you can write it is 2-pentanol. Or even you can write in this way, pentane 2O. Both are acceptable, right? You can write like this. Same as it is, if you want to write the name of this compound. This compound is, what is the name of this compound? Again, you can start the numbering from where the functional group is near, right? The superior over here, or the preference is of functional group over here. So it is 1, 2, 3, 4. So the name of this is 4-methyl. On the fourth carbon, we have methyl functional group, right? And the total number of carbons are 1, 2, 3, 4, 5 in the main chain, right? We are not considering the carbon of branch because we already mentioned over here that it is 4 branch, and it is pentane 2O, right? Just wait for Azan, bachcho. Okay, so bachcho, you have a few skill tests, right? That is your homework. You can do this as a homework, right? Few skill test questions. You need to name these substances, right? For example, if you have this substance, CH3, CH2, 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 CH, CH3, and CHO. What is the name for this substance, right? You need to know the name of this. Then, for example, if you have a second, like this CH3, CH2, CH2, C double bond O, CH2, CH3. So what is the name of this molecule? Then, for example, if you have this structure, so what is the name of this structure? And for example, if you have CH3 thrice CCHO, what is the name of this? And if you have this molecule, CH3, CH2, CH2 twice C double bond O, right? So you need to name these compounds as your homework, right? You need to name these compounds as homework, right, bachcho?
Okay, sir.
Okay, so this is what the nomenclature, or you can say that the naming of the organic compounds, right? So this is your homework. You need to complete this, and if you want to send me, so you can send, so I can check are you doing right or not. Then let's move on. If we talk about like the boiling points of these substances, so remember the boiling points are of aldehydes is a little lower than alcohols, right? So for example, if you talk about boiling point, so alkanes के जो boiling point होते हैं तो बहुत कम होते हैं, right? और aldehyde के जो होते हैं वो थोड़े से ज्यादा होते हैं alkane से, right? And alcohol के थोड़े से और ज्यादा होते हैं किससे? aldehyde. So this is alkane, this is aldehyde. So it is just for your predictions, right? And you can remember this, that alcohol with the same carbon having a greater boiling point than aldehyde, right? Right, Bacho?
Yes, sir.
Now, if you talk about the solubility, if you talk about the solubility, it is about boiling point, right? If you talk about solubility, Bacho, so solubility mein, we have a little bit soluble compounds of aldehyde. They started 1, 2, or 3, I think, like methanol, ethanol, and propanol. We can add butanol over here as well if you want to. It is a slight soluble substance. These are soluble in water, right? Because they are like C double bond O and H now. It is just like this. So we know that carbon is over here. Carbon and oxygen are directly bonded together now. So in this oxygen, we have 2 lone pairs, and this oxygen is partial negative. So it can bond with the hydrogen of water, right? That is why it is slight, or it is lower in solubility than alcohol. We know that in alcohols, they are highly soluble in the start because they are like attached with OH, right? वहां पर आपके पास OH था, जो कार्बन था वो O के साथ सिंगल बॉन्ड में था और फिर H था. So this is partial negative, and it is also what partial positive. That is why both of them are forming hydrogen bond with water. That is why they are good soluble in water as compared to aldehydes, because there is only a single bond with hydrogen or with water. So that is why it is a less soluble than alcohols, right, Bacho?
Sir, can you explain this again?
Yes, I am saying that in the previous, if you talk about like alcohol, if you talk about alcohol, so if you remember, in alcohol, the hydrogen bonding will be like this. Just talk about like this. It is aldehyde, right? It is alcohol, and it is carboxylic acid. If you remember about the solubility of alcohol, so it will be like this: a carbon or OH, right? It is just like this, now. So if you remember, so it is electronegative, and it is only single bond over here. That is why hydrogen is also electropositive. So they can bond with 2 molecules of water, right? Like if you have a water molecule over here, right? So this partial positive, and they can bond hydrogen with this oxygen. And for example, if you have water molecule over here, so oxygen is partial negative, so they can bond hydrogen bond with this H as well. So you can see this in alcohol, there are 2 water molecules that are hydrogen bonding with alcohol, right? That is why it is a little bit more soluble in water. But if you talk about aldehyde, so it is like carbon, double bond oxygen, and hydrogen. So this is actually hydrogen which is directly connected with carbon, and carbon and hydrogen have a very almost similar electronegativities. So that is why it has no charge on this hydrogen in aldehydes. So the only element over here is oxygen, which is negative over here. So when you talk about the hydrogen bonding with water, so only single molecule of water is going to be hydrogen bonded with aldehyde, right? But if you talk about carboxylic acids, so in carboxylic acid, it will be like this, right? Carboxylic acid, it is like this. So you know that it is, due to the lone pair, it is partial negative. Due to the lone pair, it is partial negative, and because this hydrogen is attached with oxygen, so there is a difference in electronegativity, so it is partial positive. So over here, one water molecule can hydrogen bond with this oxygen, right? And one water molecule can bond with this oxygen as well, right? And over here, one water molecule can form hydrogen bonding with this oxygen as well. So you can see this, the hydrogen bonding with water molecules. here only one molecule, here two molecules, here three molecules. That is why it is less soluble and it is great, or you can say that it is more soluble, right? And same as it is, they have van der Waals forces as well, right? When the number of carbons are increasing, so they will have induced dipole as well. So when induced dipole increases along with hydrogen bonding, so the melting point and boiling point are going to be increases. So it is about solubility, right? So they are less soluble and they are more soluble, and
Yes,
same
sir.
as that is for boiling points as well. So they are having low boiling point and they are having high boiling point. Now, is that clear, bacho?
Yes, sir.
Clear ho gaya, Alia? Yes. Okay. So now we can move on. When we move on with this topic, then the next thing is what? The next thing is formation of aldehyde. Yes, the formation of aldehyde. I think you all guys know this. We already did this in alcohols, right? We know that only primary alcohol are capable to form aldehydes, right? So primary alcohols can form aldehydes, right? They can form aldehydes. So the alcohol having the carbon which is attached to OH should have attached with two hydrogen as well, and it can form what? Aldehyde. It can form what? Aldehyde, right? And this is what? How can you do this? For this, you need to understand that you have acid over there, and you should have what? Potassium dichromate. You should have what? Potassium dichromate. Or even you can write like this: acid, you can use HCl if you want to, or you can use H2SO4, any acid. But over here we require H polydimines that acidify the solution, right? I prefer to use sulfuric acid over here, right? And potassium dichromate. Even you can write the full form of potassium dichromate. And for this, if you want to stop the reaction at aldehydes, you need to do what? Heat and distill product. Distill of the product, right? If you do heat under reflux, definitely you know that carboxylic acid will be formed, right? Distill of product, right, bacho? Then if you want to produce like ketones,
Yes.
so for ketone you should use what? Secondary alcohols. And by secondary alcohol you can use acid along with potassium dichromate or even potassium permanganate. It does not matter. It will form what? Ketone, because this is the only product of secondary alcohol. If you have alcohol with OH and on this carbon you just have a single individual H, and on both sides we have carbon chain. So if you do the oxidation of this, acidify with dichromate or even with KMNO4, you can even use KMNO4 over here as well, because there is not the next reaction over here after the formation of ketone. Just like in aldehydes, once the aldehyde form, even you are going to oxidize it further, so it will form carboxylic acid. But over here there is no next product about after ketones, so even you can use KMNO4 as well, because KMNO4 is very strong oxidizing agent. So if you use in the first formation of aldehyde, so it will directly convert into carboxylic acid. It will convert primary alcohols directly into carboxylic acid. That is why we are not using this in the first formation. So it will form what? It will form ketone, right, bacho? So this is actually formation that you already learned in alcohols, right, bacho? You already learned in the oxidation of alcohol. Then it is as it is, right? It is the same thing, right, bacho?
सर इसमें कोई बाय प्रोडक्ट नहीं बनेगी?
Byproduct if you want to write, so you can. Byproduct definitely बनेगी. इसके अंदर क्या product बनेगी? इसके अंदर you are removing what? You are removing over here. यहाँ से आपने एक H ये निकाला है, एक H आपने ये निकाला है. So it may form water molecules or it may form other things. But right now you are using potassium dichromate and the potassium dichromates now. So it will form the other compound as well. But we are not going to talk about such compounds. The main thing is what? The ketone formation, right? क्योंकि बाय प्रोडक्ट बहुत सारी हो सकती हैं यहाँ पर, क्योंकि MnO2 भी बन सकता है यहाँ पर, राइट? तो उसकी हम बात नहीं करेंगे, क्योंकि यहाँ पर जो manganese है या chromium है, they are transition metals, so they have a variable oxidation state, so they can form a variable compounds. But this is not in our task. We are just using KMnO4 and potassium dichromate to convert alcohols into ketone or aldehyde. So this is the main thing over here in this step, right?
Yes.
Okay, then the next thing is also known by you guys, and that is reduction. For example, if you have like for example, if you are going to reduce it, for example, if you have aldehyde, right? See, you can reduce aldehyde back to the primary alcohol, right? You can reduce the aldehyde back to the primary alcohol. This is actually what the addition of hydrogen. And the addition of hydrogen will be like this. For this, you can use reagents like you can even use number one, sodium borohydride. It is NaBH4, but it should be aqueous, right? It should be aqueous. You can use this, right? Or if you want to use lithium aluminum hydride, you can even use this, but it should be in ether, right? And the condition for this is heat under reflux. For both of them, if you're using these two reagents, so you need to do what? Heat under reflux. Or even you can use what? Hydrogen along with a nickel catalyst and 200 degrees centigrade temperature, right? So these all three reagents can do what? Can do reduction, right? So once you are going to reduce aldehyde, they are going to convert back to the alcohol. You already know this. We already did this in alcohols chapter, right? So I'm not going to strike this. I'm just going to move towards some examples, right? For example, I have a compound like this: 1 carbon, 2 carbon, 3 carbon, 4 carbon. And on this carbon, I just write a branch over here. And on this carbon, I write this. On this carbon, I write this, right? So for example, I have this molecule, right, Bacho? So on this molecule, if I am going to apply what? Lithium aluminum hydride in ether, right? And I'm doing what? Heat under reflux. So you need to understand this. What you need to understand this. This is the secondary carbon, right? Right, Bacho? On both the sides, you can see this. Sorry, this is not secondary carbon. Sorry. This is ketone, right? This is ketone, and you are going to convert this into secondary halogen or secondary alcohol, right? And this is what, Bacho? This is aldehyde. So when you reduce this, so it is going to be converted into primary alcohols, right? So that's very simple. You just need to do what? आप जैसा लिखा हुआ है इसको तो वैसे लिख दें. It is not going to be changed, right? It is not going to be changed. And these carbons, right? These carbons जो हैं, इसको आप क्या करें? You just need to break double bond and just attach OH over here and one H downward, right? And over here as well, you just need to attach OH and one H downward. और ये वाला H already वैसी का वैसी है, ठीक है? That's all, right, बच्चों?
Yes, sir.
And then secondly, for example, if I have one more very good example over here, for example, if I have this molecule, right? This is like this, and I am doing what? Adding lithium aluminum hydride over here in ether, right? And I'm doing what? Heat under reflux. This is forming what? The molecule X, and I am doing what? Adding concentrated sulfuric acid over here, right? And heat it, and it is forming what? Product Y. What is this? Now you can see this. First of all, what you need to do, you just need to see this. This is what? Ketone. Why this is ketone? Because on both ends of this carbonyl carbon, we have carbon chains, right? So this is ketone. And we know that when we are going to reduce ketone, it is going to form what? Alcohol, and it is going to form secondary alcohol, right? You just need to do what? This molecule is not going to be changed, right? And just this bond is going to be break, and OH is going to be attached, and in the bottom we have H, but we know that it is a skeletal formula, so we don't need to write H over here, right? And we know that when you apply concentrated sulfuric acid on the alcohol, you did this in alkenes. You know this, when you apply concentrated sulfuric acid, or even you can use aluminum oxide as well, and the temperature should be 350 for this. If you do this, so it is going to convert into alkenes, right? So we know that it is going to convert into alkene. So this is not going to be changed. Only the bond, this carbon has H as well, and this carbon has H as well. So you can even form double bond over here, or you can even form double bond over here as well. All right. So this is what you need to understand. This is the twist, and this is the organic chemistry. This is love. This is love. This is very beautiful. एक दूसरे से connection बहुत जबरदस्त है इसके अंदर. Right. Then for example, बच्चों, we have one more question, example question over here. Like this, we have a example question like this. This is the example number 3. For example, I have CH3, 2CO. It is reacting with what? So it will form Q, right? And then it will reacting with what to form CH3, CH, double bond, CH2, right? So you know this. This is what? This is carbonyl carbon, and this is actually like this. On both, and we have CH3, right? And it is forming Q, and after this it is forming propene, which is actually alkene. So we know that if you want to convert, or if you want to go towards alkenes, you need to convert aldehyde or ketone into alcohol first, and then this alcohol can be converted into alkenes. So simple as that. You need to apply what? Lithium aluminum hydride in ether, right? And heat under reflux. So it will form what? Alcohol, which is CH3, COH, H, CH3. And you can apply concentrated sulfuric acid at 200 degrees centigrade. So it will form what? Alkene. Right, bacho?
Yes, sir.
So this is what you need to understand in this chapter, and the rest of the things